Big Bang, age of the universe, and what really supports all of that. So think about what Edwin Hubble did. Edwin Hubble made a observation, and what kind of observation did he notice? He noticed that Earth, the universe is not stagnant, that it appears that all other galaxies are flying away from the Milky Way, and they are flying away from the Milky Way at a certain rate, about 75 kilometers per second, so really fast. So all the galaxies are like, add your own flip-flop noises, and they leave. And we can measure that. And because we can measure that, if everything's flying away from us at some point in the past, everything must have been all in one point. So everything, if we backtrack in time and we know the acceleration of the universe, we know at some point all the matter in the universe had to have been at the same spot, and then some event had to have happened where the matter came back out and flew out from this point, and that is the Big Bang. It's not even a Big Bang. It wouldn't have been an explosion. There wouldn't have been any sound from it. It would have just been a release of tons of energy into the void that would become our universe. And we know that if we take this and we draw it backwards in time, that this happened around 14 billion years or so, plus or minus a little bit. So currently we're around 14 billion, and that number gets updated, every couple of years when we get better data from measurements of what's called the Cepheid variables when we look at the sky. So the Big Bang really wasn't a Big Bang, and on this graphic it's quoting 13.7 billion years. And there's some interesting parts of the Big Bang right here where you see this kind of mottled green and blue thing at the left edge. This is where the universe actually expanded faster than light. Because it wasn't light that was expanding, because light didn't even really exist yet. What was expanding was the energy. The energy spread out. And it spread out nearly instantaneously. We're talking 380,000 years, and we see this as kind of an afterglow when we look really, really far back in the universe, and we see this as cosmic background radiation. So this is cosmic background radiation. So what are the two big reasons that we have this evidence for the Big Bang? One is this. You've got a cosmic background radiation, which is modeled. Look at how the colors are not all the same all over the place. We've got really dense stuff over here, and we've got practically nothing right here. So that tells us that when the universe was created through the Big Bang, that matter was not uniform throughout it. And that explains why we exist, because matter and antimatter should have all existed at equal amounts when the Big Bang was started, and a very small amount of our matter went out, and that's why we exist. The other is that all galaxies, sweet bird-looking galaxies, are flying away at roughly the same rate, which we can measure, and that creates Hubble's constant. And so we know for those two reasons that the Big Bang is supported. Thank you for watching. This has been Justin Higgins. Have a glorious day and be excellent to each other.